My Ampere's circuit law lacked the displacement current term, which was modified by Ampere on the thought is the current constituted when the strength of the electric field changes, and we clearly understood Oester's experiment which substantiated this thought is showing change in the strength of the electric field. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. Now in my today's session, we will be discussing a very simple chapter, what is called as electromagnetic waves. I call it simple only by weightage of marks in the second PUC examination. But strictly speaking, today's domain in physics, all research that has been happening today in physics, and probably I can also say the fourth dimension in physics is with respect to electromagnetic wave theory. But as an exposure to the subject, you have only 3 marks weightage in the exam, 1 marker and 1 2 marker. The topics that we discuss here is also confined, but as I told, it plays or it is playing a very critical analysis in the world of physics today. Now in today's class, let us make a classical attempt to understand what is called conduction current and displacement current. Let us try to understand the inconsistency of Ampere's circuit law, modification given to it by Ampere, and finally let us try to understand what actually is an electromagnetic wave. Now, earlier when you studied your moving charges and magnetism, I made it very clear saying that wherever there is electric current, there has to be magnetic field, and if at all there is a magnetic field, there has to be flow of current. And we clearly understood Oester's experiment which substantiated this thought. Now, we also told the dependence of electric field and magnetic phenomena. We told electric current is not a separate entity. Magnetism is not something which is separate. The principles of electricity is always unified with the principles of magnetism. Principles of electricity na magnetic phenomenons jote adhere ಮಾಡ್ತೀವಿ. That is where you get something called electromagnetism or electromagnetic wave theory. Now, a scientist by name James Clerk Maxwell, very important, James Clerk Maxwell showed that magnetic field is not only produced due to conducting charges but also due to time varying electric fields. Beautiful statement. ಸ್ವಲ್ಪ ಗಮನ ಹರಿಸಿ ಇಲ್ಲಿ. Maxwell shows a magnetic field is not only created due to conducting charges. As Oersted says, wherever there is flow of charges, electric current, there is magnetic field created. Maxwell says magnetic field is not only produced due to conducting charges but also by changing the strength of the electric fields with respect to time. So beautiful. All throughout, we just had an idea that if there is flow of charges, if there is conducting charges, then we have magnetic fields. But Maxwell is giving us an add-on option. He says magnetic fields is also due to time varying electric fields. Electric fields with respect to time. So, a beautiful show based on this consequence. So, understand, students, it is not only electric current, not only conducting charges, not only flow of charges responsible for magnetic fields, but it is also electric fields which change with respect to time. Good. Now, as I mentioned in the start of this session, we talk about two types of currents. One is called conduction current and the other one is called displacement current. So now we will try to understand what is conduction current and what is displacement current. Fine. The current constituted in a conductor due to flow of charges is called conduction current. The name itself defines specifically, pessimistically, what is conduction current? Current constituted in any conductor due to the flow of electric charges. ಯಾವುದೇ ಒಂದು ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ electric charges flow ಆದಾಗ ಕಾನ್ಸ್ಟಿಟ್ಯೂಟ್ ಆಗೋ ಕರೆಂಟ್ನ ಕಂಡಕ್ಷನ್ ಕರೆಂಟ್ ಅಂತ ಕರಿತೀವಿ. It is due to the conduction of charges. So my dear friends, what is conduction current? It is the current constituted in a conductor due to the flow of electric charges. Now, the current caused in a conductor due to changing electric fields is called displacement currents. Beautiful. Displace ಆಗೋದಂದ್ರೆ ಏನು? Change in the position ಅಂತ ಕರಿತೀವಿ. So this actually is Maxwell's thought. Displacement current is actually the child of imagination brought up by James Clerk Maxwell. So what is displacement current? It is the current constituted in a conductor due to electric fields with change with respect to time. So ನಿಮ್ಮಲ್ಲಿ ಬ್ಯೂಟಿಫುಲ್ ಆಗಿ ಏನು ವ್ಯತ್ಯಾಸ ತಿಳ್ಕೋಬೇಕಂದ್ರೆ, ಕಂಡಕ್ಷನ್ ಕರೆಂಟ್ is the current constituted due to the flow of electric charges, whereas displacement current is the current constituted when the strength of the electric field changes with respect to time. Displacement of electric field strength. And remember, displacement current is given by the expression, this is very important, exam ಅಲ್ಲಿ ಯಾವಾಗಲೂ 1 ಮಾರ್ಕ್ ಕೇಳ್ತಾರೆ, expression for displacement current. ID equals epsilon naught d phi e by dt. What is d phi e showing? Change in the strength of the electric field with respect to time. It is the rate of change of electric field strength. Ade alva displacement current andre. What is this epsilon naught? Permittivity of free space. You remember when we did electric charges, wherever there is electric field, there has to be epsilon naught. Wherever there is magnetic field, there has to be mu naught. So displacement current ID is equal to epsilon naught d phi e divided by dt, where d phi e divided by dt is the rate of change of electric field. Now, going back to our Ampere circuit law, we told the line integral of the magnetic field vector b dot vector l is mu naught into I, where I was conduction current. So here magnetic field is related only to conduction current, but Maxwell is clearly saying no, a magnetic field can also be created due to time varying electric fields. Magnetic field can also come into picture due to displacement current. So this Ampere's circuit law needed some modification, some change, and that change was done by Ampere. And if you observe here, Ampere's modification is given by vector B dot vector dl is mu naught I. Yes, I understand. It is partly due to conduction current, but also due to displacement current. Mu naught epsilon naught d phi E by dE, and this is called Ampere Maxwell equation. So very clearly you see magnetic field is existing due to the presence of conduction current as well as the displacement current. Clearly the second term is giving me displacement current. So the equation is modified, and the modified equation is called Ampere Maxwell equation. So my dear students, please to understand, conduction current only due to moving charges. Displacement current due to time varying electric fields. My Ampere's circuit law lacked the displacement current term, which was modified by Ampere on the thought of Maxwell, and therefore that expression is called Ampere Maxwell equation. Now students, based on the idea of conduction current, displacement current, and Ampere's modification, we will try to understand the talk of the town today, something called electromagnetic wave. So if you observe, the word electromagnetic wave is composed of both terms electric and magnetic. The words electric and magnetic amalgamated together, coalesced together, ಒಟ್ಟಿಗೆ ಹಾಕಿ, we are getting something called electromagnetic wave. ಅಂದ್ರೆ ಆ ಒಂದು electromagnetic wave ಅಲ್ಲಿ electrical phenomenons, electrical effects ಹಾಗೂ ಮ್ಯಾಗ್ನೆಟಿಕ್ effects ಎರಡೂ ಪ್ರೆಸೆಂಟ್ ಆಗಿರುತ್ತೆ. Therefore we say electromagnetic waves are which there is sinusoidal variation. EMI ಅಲ್ಲಿ ಅರ್ಥ ಮಾಡಿಸಿದ್ದೀನಿ, ಆಲ್ಟರ್ನೇಟಿಂಗ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಅಲ್ಲಿ ಹೇಳಿದ್ದೀನಿ. ಸೈನ್ ವೇವ್, sinusoidal change, sine curve. So in an EM wave, there is a sinusoidal variation of electric field vector and magnetic field vector. ನೋಡಿ ಇಲ್ಲಿ electric field vector ಇದೆ, magnetic field vector ಇದೆ. So an EM wave is composed of an electric field vector as well as a magnetic field vector at right angles to each other. Key word to understand EM wave, which means the vibrations of electric field vector and magnetic field vector are mutually perpendicular to each other. Therefore, what we say is an EM wave comprises of vibrations as well as oscillations. So, it is a sinusoidal variation. We have electric field vector, we have magnetic field vector, and both of them vibrate, yes, mutually perpendicular to each other. So if you observe the diagram, the right shade is the electric field vibrating, and the blue shade is the vibrations of the magnetic field. And very clearly, along the direction of propagation, x, y, z axis, they are perpendicular to each other. So, electric field ಮತ್ತು magnetic field ತನ್ನ ಡೈರೆಕ್ಷನ್ನಲ್ಲಿ ಮ್ಯೂಚುವಲಿ ವೈಬ್ರೇಟ್ ಆಗುತ್ತೆ. ಈ ಒಂದು ಕಾಂಪೋಸಿಷನ್ ನ EM wave ಅಂತ ಕರಿತೀವಿ. So please to understand, an electromagnetic wave comprises of an electric field vector as well as magnetic field vector, and they vibrate mutually perpendicular to each other. Now, what is the source of an EM wave? It is an accelerated oscillating point charge. An extremely small point charge accelerated to high potential. Such point charges generate something called EM waves. Scientist Henry Hertz experimentally confirmed the existence of EM waves. One mark ಪರೀಕ್ಷೆನಲ್ಲಿ ಕೇಳ್ತಾರೆ, name the scientist who experimentally confirms the existence of EM waves. Henry Hertz. And what is the nature of EM waves? Gotaitu sir, when electric field and magnetic field vibrate mutually perpendicular, it has to be transverse in nature. So dear students, today we studied current due to moving charges was called conduction current. Current due to time varying electric fields was called displacement current. And magnetic field exists due to both of them. And we also studied modification done by Maxwell. Now, we studied what was an EM wave. It comprises of both electric and magnetic fields. The vectors vibrate mutually perpendicular to each other, and they are transverse in nature. In my next session, we will understand the properties of EM waves, the electromagnetic spectrum. Until then, have a great time. Thank you.